Now let's move to the next type of technical classification. We have the first one, which is the magstripe card, still prevalent in many countries. The magstripe cards have a certain lacuna. Lacuna number one, that they have tracks which are read only, which means they cannot process any transactions on their own. They can only be offered to the terminal for reading purposes. They cannot carry your payment applications the way we have been speaking about just now. There will be no AID so far as your magstripe card is concerned. It only carries the basic data of the card holder. It does not carry any issuer regulation. It does not carry any processing capacity. So this is lacuna number one. It is read-only mechanism, not read and write and process mechanism. The second lacuna in magstripe cards is that they are simple and easy for copying. You can create a counterfeit card very easily when you are using the magstripe card. The third problem is that when the magstripe card is used, since it does not have any processing capabilities, we are not able to generate any session related keys or cryptographic keys when we are using the card. This is the third issue. So they are basically creating problem from the security perspective. This is at a broader level our problem number one. We have another problem. The problem number two which you have is that the magstripe cards, since they are read only, are not capable of processing any transactions on their own. All such transactions have to be processed only by the issuer switch. So every time you swipe your magstripe card, the message has to start from the terminal, then to the acquirer, through the network, it has to go to the issuer. Then the issuer looks at the transaction, approves the transaction, then the transaction response travels all the way back from the issuer all the way to the terminal, which means you need huge bandwidth for moving the messages up and down. One message from the card up to the issuer and a response from the issuer back to the card. This creates an issue of requirement of bandwidth. This also increases the time involved in the transaction processing. So the cost and the time involved is when we use the magstripe card. This is problem number two. And with this increased time gap and the increased length through which the message moves, there is a possibility that somebody may hack into this message while the message is in transit all the way from the issuer, from the acquirer to the issuer and back. So security issues again crop up because the message has to travel all the way up and down, exposing the message to various hackers during the transit. So our basic problems for magstripe are security, number one, and two, cost and the time involved. So to overcome that problem, this concept of chip cards or smart cards started in France. They created smart cards, where on smart card we'll have the processing capability. So we have the smart cards, which I'm going to call as EMV cards or ICC from this point onwards. So on an ICC, an integrated circuit card, you will have the applications. The applications will now have the capability of processing the transactions. I could have a mathematical processor. I can process the transaction within the chip itself, which means the transaction can now be processed only between the terminal and the card. I don't need to speak with the issuer at all. The card itself acts like the issuer's switch and the transaction gets completed there. That is one possibility. Second problem which is going to solve is the time and the cost involved because of long communication network. Now since the transaction can happen only between the card and the terminal, my transaction time is very small, only interaction between the card and the terminal. The cost involved becomes less because my network requirement goes less and my time gets reduced because instantaneously the transaction can get processed. This is how we have overcome the issues which are created by the magstripe cards.
So just a question, when we swipe a EMV card, then the communication is restricted between terminal and card, but then how it would check out about the balance and other stuff?
It would not. Then the card has to have all the information which the issuer has.
So basically are you saying that the card does have the information of what balance we have right now?
Very right. The card will understand, the card will think like the issuer.
Okay.
Which means to think like the issuer, the card needs to have all the information which the issuer has. So we'll do it that way.
Okay.
So basically it is a replica of issuer in terms of that particular card.
I will not say it's an exact replica of the issuer. It's let's say a small replica of the issuer. Everything which the issuer has is not on the card. But what is necessary for processing the transaction is on the card.
Okay.
The issuer will have a large amount of data,
Yeah.
whereas we'll have only small required data on the card.
I have a lot of questions now. So consider this where let's say I have $100 balance in my account and then I am able to extract that amount. Now I have a zero balance, right? But then the card which I am swiping right now, EMV chip, it still reflects $100.
It will not, because there is a process. See, Girish, one point. If you are thinking of the problem, the issuer is also thinking of this problem. So, if your card has $100 and at the terminal the balance has become zero, we'll update the card by this information that now the available balance is zero. Okay, so even though we are saying the transaction may get completed between the card and the terminal, it's not that the card is not speaking with the terminal. Sorry, the issuer. The card is still speaking with the issuer and getting updates continuously.
That's what my question is. So basically, somehow it is picking up with issuer.
Yeah, so I'm going to talk a little later about a process called scripting. In this process called scripting, I'm going to update the card and the issuer are going to be in sync with each other.
Okay.
Otherwise, if one is thinking left and the other one is thinking right.
And even if it is a different bank altogether, still they are...
they are still speaking with each other. The distance does not matter. They are still connected electronically.
I have a question.
Yes, sir.
With regards to the magstripe card, you said it reads and it increases bandwidth and security, and this gap was closed by the smart cards that does the processing. So I was just concerned, how does it close these two gaps, the bandwidth and security? How did the smart get this?
Okay. So what I would request you to do is hold your question till I reach the EMV transaction processing. In EMV transaction processing, we are going to speak about how all these gaps are closed. So will you hold your question till that point?
Sure.
Yeah. So I'll explain how this gap is met and how we overcome these issues. Another point I just want to put in your mind at this level or at this stage is that though we are saying that this gap is met, we are not saying that this gap is met 100%. Nobody is saying that EMV cards are a complete solution to the problems created by magstripe. We are having a partial solution, but that does not mean that this solution is 100% clear or correct. EMV cards also have problems of frauds, also have problems of copying of those cards. Skimming can still be done with the EMV cards. So we will deal with this when we reach the EMV processing. Are we okay?
Yes, clear.
Yes, sir.
7810 is for magstripe and 7816 is
7810 is for magstripe, 7816 is for chip cards. Okay. Now this is the second one. The third one is contactless. So in a contactless, what is the difference? Only instead of inserting the card, I am going to wave that card. That's the only difference. Otherwise, the basic process of a contact card and a contactless card is identical, not much of a difference. The next type is called as the near field communication cards. In the NFC cards, near field communication cards, I don't need to have that plastic form. What I need to have is either a chip or only the application would also do. I need to only have actually what your chip has is nothing but the payment application. So if I load this payment application on any device, any chip, it is still going to act like your card. So I could have somebody having a chip or the application in a mobile phone, like this Apple Pay example or your Google Pay examples or a Samsung Pay. I could have the chip in a ring which I am wearing, maybe on a wearable like some kind of a bracelet which I am having or a locket which I am having. Some companies are thinking of implanting that chip below the skin, so you don't need to carry anything, you simply wave your hand and then that could be done. That's the way you could have your card classifications, which the NFC cards which are going to work. So in NFC card, I really don't need the chip also. What I need is the application, and then your SIM on the mobile phone is nothing but a chip. I can again load your payment application on the SIM card of your phone, on the chip on your phone, and then your phone will start acting like your debit card or the credit card. So in this way, I could have the next classification, which is the near field communication. We are going to dive deeper into this at a later point. I am just introducing the broader level categories.